Hi, my name is Tanshini, and now I would like to explain about Part A and Part B. Part A is DC circuit with DC simulation without a parameter switch, and I will show the result now. By using the QCS software, we get this, and we draw the same circuit, and we will get this value for the Vout. And follow the instruction. They call us to change R2 with values 100, 200, and 300. So right now I will show you how to change it. And we just click on the properties and then change it to 100 and then just click on the simulate. And now this will be, the result will become difference, and this is the result for the 100 ohms. And then we change to 200 and the voltage become 3.33 watt for the Vout. And then we change to the 300s and we get 4.29 for the voltage out. And then they call us to compare the measurement reading with calculations, so we compare it with the formulas. For the formulas, it is use R2 over R total, which R1 plus R2, and then multiply with the voltage source. And so for the 400s, we will get 400 over 800, and then multiply with 10, and we get 5. For 300, it will become same, then it will get like that. So I will prove it right now. So 400 over 800, and then time with 10, it will get 5. And for the 300 over 700, and then multiply with 10, it will get 4.285. And after we convert it, it will become 4.29. So the calculation is correct compared with the value that we get in the software. And now I will explain about Part B. The Part B is the same circuit but on a parameter switch, and then it will have a change at the R2. The value will become the R out. So let's see it. Here's, we already changed the value, become R out. And then we also set the parameter switch with the properties that show in the left sheet. And then after we simulate, we will get this for it. And we can look that for the 100 resistor, it will get 2 for Vout. For the 200, we will get 3.33, and for 300 we will get 4.29, and 400 we will get 5. So it is same with the value shown without the parameter switch. And the difference between the parameter switch and without it is, if without the parameter switch, it will only show the voltage for the voltage we set in the R2s, but for the parameter switch, it will show all the value for all the register. So we can see that it many from 0 and until 1000, and this is the difference for the parameter switch and without it. And that's all for me for Part A and Part B, and thank you.
Hello, my name is Muhammad Rehan bin Razwan. My number matrix is B012010136. Okay, I want to explain about Part C, simulation without and with parameters with 4 AC circuits. For number 1, number 2, number 3, and number 4, and number 5, we need to do like figure 3. They have given, we need to put AC, current, voltage, resistor, ground, and the voltage here. This is a voltage probe. Do like the like figure 3. So this is what I'm doing right now. We put the component. So from here, okay, I'll show you. We need to emulate. For the R1 is 50. Tablet. We need to know the current and voltage. So this the current here 4.8 and the voltage 250. We need to change the R1 here to 100, 150 and 200, just like this. Just like it. I already done it. R equal 50, R equal 100, you can get 2.4. R equal 150, you can get 1.6, and the last one is R equal to 100 and you can get 1.2, the current. So let's look into number 6. By adding the parameters we set R1 equal to R out. That means we need to set the R1 is equal to R out and put the parameter switch here, and we need to know set the start from 50 and stop to 100, and we can we need to emulate first. Okay, and click the tabula result, and we need to find the current and V for the voltage. You can get the data here. So you can see the 50, 100, and 50 and 200 for the current 4.8, 2.4, 1.6 and 1.2. Okay, let's look into the number 7. Observe the switch with different frequency and different value of resistance. So the frequency is 50, 60, 70, 80, 90 and 100. So the different value is resistance. So the different value is resistance is 50, 100, 150 and 200, and you can get the answer here. 4.8, 2.4, 1.6 and 1.2. The voltage is still the same, 1 to 150. Okay. For the number 7, observe the switch with different frequency. For number 8, explain the difference between. For number 8, explain the difference between with switch and without switch AC simulations. So the difference is for the AC. If we put the AC, we can get the answer, and the simulation will run properly. If we put disable here, this means there is nothing here. We emulate, and you can see that have an error because they not have the AC here. If we put AC simulations, we can get the answer just like here. Okay, so for the number 9, explain the difference between DC simulations and AC simulations with and without. So to make it easier, for the AC simulation is for the software, we can run properly and get the best result, the data. For the number 10, by using transient simulations, test and plot the graph for resistance R1 equal 100, 150 and 200. That's mean here. So they said by using transient simulation. So this is transient simulations. You can see the stop, the step, the start is 0, number is 31, and you can get the graph here. The R1 we need to put 100. Here, and try to apply, emulate. We need to find the current. the current first. And this is the voltage, the graph from the voltage. Okay, so this is the result. Or we go to number 11. By using transition simulation and switch parameter, by settings R1 equal to R out, plot graph by ragging the R out 100 and 200. So that's mean we need to put the parameter switch and put this sets 100 and 200. So we need to start 100 and stop 200. And you can see the graph here, the data here. You can see three waves since input, just like that. They have three different waves, and this is R out, and you can see the current and the voltage. Okay, next, for the number 12, explain the graph by transients and without speed parametric. So I want to explain that if we put parametric speed, it will give you can simplify it easier. Just we need to one graph with three wave. By combine three graph become one. If we don't put the parameter speed, we need to do step by step, like one graph, two graph, and three graph. That's all for me. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Nim Muhammad Syabir Abdul Samin. The metric is B0120104142. For this video, I want to explain about my task. That I do two tasks. Part A, three-phase connection, and part D, power measurement. Okay. I begin for the first part is part D. This using the similar circuit as figure 3 and by using transient simulation. The circuit figure 3 ni that's from part C. Set the supply voltage to 240 volt and connect to load Z for each case below. That's mean A, Z resistor value of 230 ohm, B, Z capacitors load 10 millifarad, 50 millifarad, C, Z inductive load from the inductor module 1 Henry, 1 millihenry, 10 millihenry and 50 millihenry. For this resistor and capacitor in parallel, use value from A and B. And for E, Z resistor and inductor in parallel, use A and C value and tabulate and plot the result. Okay, let's begin. Okay, this is for the part DA. This the circuit from the part C that we will need modify the value or component for this here. This for the 230 ohm. When we simulate, we can get the two graph. There's V is voltage, and this the combine from the voltage source and current probe that we can get this graph. And these are the tabular table for this circuit. Next, we go to the part DB. Part DB, we need to modify this here to put the capacitor that's value in 10 millifarad that I choose for this example. We can get on the graph is A1 in current probe, V1 in uh, voltage probe, and V2 for the voltage source. Then we can see the tabular table for this circuit, the value, and the next we can see the part DC that I choose is 1 millihenry. We can see when we simulate V5 is a voltage source, if V4 is the voltage probe, A4 is a current probe. We can see this is for the graph for the circuit part DC 1 millihenry, and this is the tabular table for the circuit. Next we go to the part D. For this is we need to parallel two component, that's mean resistor and capacitor. Resistor we can get from the part DA, that's 230 ohm, and capacitor is 10 millifarad. I choose for this circuit to show. Then we can get, when we simulate, V2 is a voltage probe, A1 is a current probe, and V1 for this graph is a voltage source. Then we can see this the table for this circuit. Okay, the last we go to the part DE. I choose for 1 millihenry. That we can see it's parallel resistor and inductor. When we simulate, we can get the graph V2 is a voltage probe. This is the graph, and A2 is a current probe. This is the graph. We can see. Then the last if V11 is a voltage source. Next, this the tabular table for this circuit. We go to the last part is part E, three-phase connection. For this part, we need use the another software that's named in LT-SPICE. For this part, sketch the circuit connection based on A, data connection, and B, Y connection. By using LT-SPICE software, design the three-phase connection system as in A and B. Connect to the load RL with appropriate value based on your own selection. Connect the input AC supply voltage 120 volt 50 Hz and simulate and plot the output of graph of current and voltage. For this time, we need to find the current graph and voltage graph. Okay, let's begin. Okay, this LT Spice software that we can see from the right is a data connection. I already sketched this circuit. When I run this circuit, we need to find the voltage graph. I choose this. I select all for this voltage and I select OK. Okay, that we can see the sine wave graph. For this graph, we can find the voltage from the uh, sine wave are similar like this, green and purple. This for the voltage graph for this data connection. And another we can delete for this blue, delete red, and this blue again. Okay, this is for the voltage graph. And we can find the current graph. I choose the RAB, RBC, and RCA. I choose OK. Okay, this for the current graph that we can see it's similar. Three sine wave are same higher, and this bottom, and this for the current graph for this data connection. Okay, next we can go to the YY connection. For YY connection, I simulate this. I need to find the voltage graph. I choose this, and I choose all for this voltage. I select OK. Okay, we can see for the value of the voltage graph for YY connection is that's color blue, red, and green. For another color, we can delete, for example, blue, purple, gray, and green. Okay, this for the voltage graph for YY connection. Okay, next we need to find the current graph. I choose this. I choose current from IV1, V2, and V3. I select OK. Okay, this is for the current graph that we can see. The higher is same. The bottom highest is for that's same on all also that we can see. The graph for the current graph for YY connection. That's all for me. Thank you.